So this presentation will cover two sample hypothesis testing for the proportion. When we were in class the last time, we talked about two sample tests for the mean, and we did some examples of z-tests and t-tests. Now we need to do an example for qualitative data, or data that you would need to count. And there will be occasions where you want to compare two groups and you want to compare the responses within those groups. This test, is exactly like all the others, where step one, we define the null and alternative hypotheses. This is a proportion test, so the Greek symbol that you would use here is a pi. One-tailed tests will use a question like, is there more, is this less frequent, type of thing. And you can see there the greater than, less than options available. The equal sign, remember, has to go on the null. These tests are also performed using the difference between proportions. So that's why it's set up this way. But of course, we're used to it appearing in this format, where for the first example, the alternative says the proportion in group 1 is less than the proportion in group 2. That could mean young people do this less often than old people. It could mean something like that. Two-tailed tests, as you hopefully remember, use comparisons like the same as or there is no difference in. And again, this is a comparison of differences, or you could rearrange it where we compare group 1 and group 2 directly. The null could say something like men and women do this at the same frequency or at the same rate, where the alternative could say there is a difference in the way that men and women participate in whatever activity. The example that I will use is about some practices in lending, and we're going to look at some data on mortgage refusal rates to see if there are any disparities in these rejection rates. So the question is there a reason for concern behind some of the differences that you'll see in refusal rates? So there is a file in Desire2Learn called the two sample for proportion. It's a template just like we're used to using. That yellow box with the mortgage data is not there, but it is here in this video, and you can go back and forth as you need to. But this template looks very familiar to the other templates that we've used. We're going to set up a test to see if there's a reason for concern behind the data. So the first thing that we should do is let the data guide us. So let's see. What is the data suggesting? So I'll give you a minute to take a look at the data. There are 91 refusals total, and those have been organized by minority and by income. So if there is no reason for concern, the minority refusals would be no higher. So we could say that race is not a factor in rejection rates or in lending practices. If minority refusal rates are no higher, we could say that the minority group is group 1 and the non-minority group is group 2. The alternative would say that there is reason for concern, minority refusals are higher, where group 1 has a higher percentage than group 2. So when we set the test up this way, does this suggest a one or a two-tailed test? Well, there is some direction in there where we're trying to figure out which rejection rate is higher, so it is a one-tailed test. So for the template to work, you would need to type in the 1. The next thing we need to do is fill in some of the input data. We're not going to look at income yet. We're just going to look, I guess, by race. So we'll lump the two incomes together. And as I mentioned before, the minority group is group 1, the non-minority group is group 2. And there are 37 plus 27 minority refusals out of the 91 refusals total. And 16 plus 11 refusals to non-minorities out of the 91 refusals total. So when you put all that in, we have 52.8% refusals, 52.8% of the applications or refusals to minorities, 29.7% are refusals to non-minorities. So that's step 1. We need to move into step 2, and hopefully you're getting familiar with calculating the test statistics. We need observed values and critical values. One of the observed values we need is Z observed. Hopefully you remember that for proportion tests, we're going to use the normal distribution. So we would have to calculate the Z-score. Now we've calculated the Z-score before. This is where you take the sample value and compare it to a population value and pull in the standard error. The difference here is that now we have two groups. Since we're comparing the difference between means, we'll take the sample value of the difference. If you look here, P1 minus P2, sample value of the difference between proportions. And then we'll use the population value, that's the population value of the difference. And in the denominator, the standard error. And this is how you would calculate the proportion between two groups. So that P bar is the common proportion, similar to an average, but that's the way that you would combine it and incorporate both sample sizes. So you would do this in the standardized function, just like we did before, and similar to what happens in the tests for the mean, that middle parameter goes to 0. So the first thing we would put in there is the sample value of the difference. The second thing we put in there is 0. And the third thing, you're actually just going to click on the box that calculates the standard error for you. Now this is a Z-test. So the Z-test formulas you should be very familiar with. They're already in the spreadsheet. We've already calculated these by hand. So I hope you're still comfortable and hope you still remember them. But those are in there for you. So step 2 is done. All the calculations are in there. And now we're ready for step 3, where step 3 is the same as it has always been. If the absolute value of Z observed is bigger than critical, then we would reject the null. If p-value is less than alpha, then we would reject the null. So let's go back to our data. So we have this one-tailed test, and our input data filled in, and you'll see the standard error and pooled proportion are filled in as well. And when you get everything going in there, and you may have to type in the significance level, that's 5%. If we look at the top two numbers, those are Z-scores. We have the observed value from the data is about 3.2. Our critical measure is about 1.6. Observed is bigger. A p-value is 0.001 compared to significance, which is 5%. P-value is smaller. So when you do all this, we end up rejecting the null, which says minority refusals, or the percentage of refusals that go toward minorities is higher. So there is reason for concern. So we are going to reject the null. Now that we've done the overall test together, I would like you to look at either the high income scenario or the non-high income scenario and do that one on your own. And that should be what you upload into Desire to Learn. it would be grouped with homework 10. So it would be one of the elements of homework 10.